Hi everyone, and welcome to another episode of Silicon Minds, Human Hearts. Today we'll be talking with Darshna, who's the Chief AI Officer at Elastacloud. Good afternoon, Dasha.
Good afternoon, Zoe.
Thank you for joining us today. Can you please introduce yourself?
Yeah, absolutely. I'm Darshna Shah. I am the Chief AI Officer at Acora, and I'm also a Microsoft AI MVP.
Okay. What does a Chief Innovation Manager do?
A Chief AI Officer is a relatively new role to the industry, but has become more and more prominent, I think, given the horizon event of generative AI arriving onto the scene, and it really unlocking a cascade of mass adoption of AI. So nowadays, more and more businesses are racing towards implementing AI in their everyday operations and functionalities, which is not always a simple task in such big, complex systems. So there is a need for an AI officer to do things like define strategy, ensure the right solutions are implemented. Common kind of concerns of most organizations with AI is, yes, they want to quickly adopt it and for the solutions to be accurate, but there is also an element of risk associated with that, where in certain highly regulated industries like finance, you'd need the compliance element to ensure that you're not breaking any regulations. Likewise with security, and also there is heavy investment involved, which most people would like a nice return on. So a Chief AI Officer helps with all of those components and ensure that you're kind of staying one step ahead and ensuring the latest technology is being adopted as performantly as possible.
Any coding for you anymore?
Yes, I still, that is one of the things that is a must for me. I think that's where, I guess, so I come from a science background. I was a neuroscientist before I entered the world of tech. And I think there is a really kind of core part of me that craves that creative element. And whether you're applying that to a neuroscience experiment or you're creating code and developing cool solutions, that is what attracted me to tech in the first place, with the ability to actually make practical, real life changes. So if I lost that, I think I would be kind of lost as a person in general. So I definitely try to keep involved in coding at least once a week. So yeah, if I'm not on a project, it'll be my own personal projects that I'll be coding on.
How did you go from neuroscience into tech? It's an interesting move.
Yeah, it is a very interesting move. My career path has not been a straightforward one, but I think all the best stories are like that. So I actually originally wanted to go into clinical psychology and help people with depression and a lot of psychological issues. Quite early on, I got some expertise and I did some volunteering work with a charity called Headway, and they help patients that have gone through some sort of brain injury and are in the process of being rehabilitated. That was very emotionally rewarding, but it was missing the intellectual stimulation that I was craving, I think. So I went on to do a master's and a PhD, and I really enjoyed the whole analytical process of it, defining a hypothesis, designing your experiment, thinking about it from so many different angles in terms of the existing research, how you can bring something novel to the industry, and then giving that back to the research community and the broader society as a whole. So having really enjoyed that, I started looking around and what I wanted to do. Really, so my undergraduate was with a psychology with cognitive neuroscience, and I really liked the neuroscience element of it, but the thing that I didn't like it, that undergraduate, a lot of the research was very correlational, and I wanted something that was a bit more impactful. I wanted concrete results that I could say cause and effect. So I went back to kind of hard science, and my PhD was looking at mechanisms of drug-resistant epilepsy, which was fascinating and really difficult in many different aspects. One particular thing was the balance between doing the lab work and keeping up to date with the research. Whilst that was like a phenomenal experience that I will cherish for my whole life, it was very isolating. So academia is all encompassing. There's very little time for much else in your life. And it was great that I could kind of push the boundaries of innovation in that field, but they were very small innovations, and I wanted to do something a bit more where I could see the results and the benefits to everyday life for people. So I was looking around and how I could use the skills that I had from an analytical and a research perspective in other fields. And at the time, data science was being paraded as the sexiest job of the 21st century. And I was like, I've never heard of this. Let's see what it's about. So I went to a few careers fairs at the time and came across one of the largest boot camps at the time, a company called Pivigo. They were running a program called Science to Data Science, and they were taking people from postgraduate research and giving them exposure over a shorter period of time to the real life applications of statistical and analytical work. So I got accepted onto that program, and I worked alongside a company in a team of 8 with a company called Investec in the finance sector. And we were challenged with the kind of hypothesis of understanding how their asset managers perform, and are there any kind of clusters we could identify that could help them improve their renewal of contracts and things like that. So we did a whole unsupervised learning experimentation. We took in all of that data, cleaned it, analysed it, and delivered the results back to the business. And I was hooked on data science from that moment, because it's one thing to read about all of the hype, but to actually live it is a different thing. And I was like, yeah, this is very powerful. I can see applied in the right ways, you can have huge benefits. So I was frantically at that point trying to write up my PhD thesis and also look for a career in data science. Very quickly acquired a data science position in a consultancy, and the rest is history, really. I've just been in the field for the last decade doing various different data science projects.
It's an interesting path.
Yeah.
But one thing that came out was, you said, and as during your PhD, you had your time in your lab,
Mm-hmm.
and then it was hard to keep up with research.
Yeah.
Is that the same these days?
Yeah. I think since GPT and generative AI has exploded, it has definitely been, it's hard, and the tools are coming out so quickly. There are solutions we've implemented with LangChain, for example, where functionality becomes redundant very, very quickly. LangGraph is the new hype these days, and just keeping up with all of that can be very, very overwhelming. But I think I was lucky enough to work with a team that are not afraid of innovation and new tech. And we have a culture that really allows us to play with tech, which I think is really fundamentally important within organizations, because the minute you start putting a lot of red tape around, you can do this, you can't do that, you need to be careful of this, which is necessary. But I think if you can create the environments, like sandpit environments and playgrounds where people can experiment, that's how we can kind of maintain pace as well as keep innovating.
I think that's important for a business, that they can keep on just trying things also.
I think within reason. So I think the other thing that's lacking within industry these days is education around data science and AI capabilities. So I work with a range of different companies from all different sizes, and some of them who typically do have pre-existing teams are kind of further ahead on the curve and are aware of the capabilities of what you can and can't do with the data that they have, and have typically experimented to some degree. There are other industries, like the legal industry, for example, which I think historically has been a little bit slower to adopt new technology and are quite risk averse naturally. But at the same time, they haven't, there's that education piece that hasn't quite kept up. And I think in certain circumstances that can lead to unrealistic expectations, particularly from key decision makers, around how to apply tech in the right way, and the kind of expectation around how it will perform and what is needed to make it perform. So I think education and creating those safe playgrounds to experiment in are the two critical components that I think most organizations would need in this day and age to adopt AI successfully.
Are there particular items that you've seen now already that is like, this is going to be a game changer in the industry?
I get asked that quite frequently, and I'm quite reluctant to give an answer just because, as we've discussed, the pace of change is so rapid that it's quite difficult to see how people will apply certain technologies and how that will lead to further developments. I think there are, in terms of development tools, there are kind of certain tools that I would say, yes, they're probably leading ahead. But how that will change in the next few years, I would be a little bit apprehensive to say, yeah, I think this is going to be the next big thing.
That's being reluctant on that, I fully understand, because it changes so fast.
Yeah,
it's
exactly.
hard to stay like, okay, that's going to be the next big thing.
Yeah.
Where do you think we will be in the next couple of years?
So I think we will probably, just looking at the pace at which people are adopting generative AI, I think we will definitely see it in a lot more places. I think there will be better practices and playbooks as to how to get generative AI solutions integrated within businesses, and probably a concrete set of tooling. I think certain things will become obsolete because we would have worked through those problems. But then I think some things will come back. So as a data scientist, I was just having a conversation actually a few minutes ago where I was talking about the typical workloads that I have today versus 5 years ago, and it is completely different. So there are certain skills that a data scientist has that we wouldn't have put previous emphasis on, that we're putting much more emphasis on now, because we're not doing so much of the machine learning model development and more applying of existing models. But there are other skills such as kind of business knowledge and asking the right questions in order to know how to design the best solution with the best parameters in place. And then also on the evaluation aspect, understanding, well, what do we need to bear in mind when we're designing and developing in order to kind of ensure successful results at the end of it. So there is that communication aspect and also the engineering component. So before, a lot of our time would have been spent on kind of cleaning data, ensuring it is of good quality. I mean, that is still needed, but not to the same degree it was in the past. And likewise nowadays, it's kind of, we are just putting a lot more emphasis on how to make things scalable, secure, with lower latency for the users, and really focusing on that user experience. So the design elements of the AI solutions are more focused on the engineering elements as opposed to the development of the model itself. And then I think, so there's a slight shift in that. I think some other things will come back around. So at the minute, there is a lot of emphasis on LLMs and generative AI capabilities, but is what I'm also seeing is in certain scenarios, people have gone back to data science, like pure machine learning development, because explainability might be a prominent requirement for them. And if they want to use those explainability components for other workloads going forward, of course, you can get groundedness kind of metrics and citations from how LLMs have come to a certain answer. But to actually reverse engineer the entire how the models work, that's pretty impossible. So where explainability is a core component, you can see that people are looking back towards traditional machine learning. And I think when the kind of hype cycle dampens a little bit more, we might see more of a balanced view of people considering what is the actual right approach as opposed to using the latest technology.
It's an interesting thought. And indeed, we need to get over that hype to make everything a bit more balanced out. But we see, I think, now already the last couple of months, there's quite a lot of things that have been starting to balance out.
Yeah.
So it's nice. What kind of advice would you be able to give our audience? Can be business people, can be data scientists. What do we need to look into? What do we need to be taking care of?
So I mentioned too before, kind of the playground to create that environment where people are comfortable to experiment, and obviously the skills side of things, just to ensure you're leaning in, being aware at least of the latest technology and advancements that people are proposing. The other thing I would probably say is probably around diversity. So one thing I see that has changed, and I think it's a good change, is that because we have so many more powerful tools at our disposal, there is more emphasis on how we can make more holistic solutions. And for that, it's not just maybe like a business decision maker with the technical team, but you'll also get a lot more conversations with designers, for example, around the user experience, with different domain experts around understanding the data in more depth and how that can be augmented. So I think that's a really fascinating prospect, and I think we should lean more into that as well, because I think that can drive even more innovation. So yeah, I would say just speaking to more people and leaning into those conversations.
Okay, thank you very much for that advice, Darshna. We hope to hear more from you in the future, but already meanwhile, thanks for joining us today.
Thank you so much, Sammy.